Hello everyone, this is Sanjay from CSIQ branch. Today my concept video topic of data structures is what is radix sort. Demonstrate the MHD radix sort with an example. Okay, now let's jump into the topic. The lower bound for the comparison based sorting algorithm, merge sort, heap sort, quick sort, etc. is n log n, that is, they cannot do better than n log n. Counting sort is a linear time sorting algorithm that sort in O n plus k time when elements are in range from 1 to k. What if elements are in the range from 1 to n square? We cannot use counting sort because counting sort will take O into, which is worse than comparison based sorting algorithm. Can we sort such array in linear time? So the answer is radix sort. The idea of radix sort is to do digit by digit sort starting from least significant digit to most significant digit. Radix sort uses counting sort as subroutines to sort. The radix sort algorithm do the following for each digits I where varies from the least significant digit to most significant digit. Here we will be sorting the input array using counting sort or any stable sort according to the ith digit. Unsorted list, and here we having example of unsorted list where 170, 170, 45, 75, etc. Sorting by the least significant digit, ones place queues. Notice that we keep 802 before 2 because 802 occurred before 2 in the original list, and similarly for pairs like 170 and 190, 45 and 75 where the last digits are equal. So 170, 90, 802, 2, 24, 45, 75, 66. So here in this sort, like, we are checking the last digit, and with the last digit we are sorting the list, sorting by next digit 10 place given. Notice that 802 comes before 2 as 802 comes before 2 before in the previous list. 802, 2, 24, 45, 66, 170, 75, 90. Sorting by most significant digit, hundreds place gives 2, 24, 45, 66, 75, 90, 170 and 802. What is running time of radix sort? Let there be d digits in input integers. Radix sort takes O d star n plus b time, where b is the base for representing numbers. For example, for the decimal system, b is 10. What is the value of d? If k is the maximum possible values, then d would be O log bk. So overall time complexity is this, which looks more than the time complexity of comparison based sorting algorithms for large k. Let us first limit k. Let k is greater than or equal to nc, where c is constant. In that case, the complexity becomes O n log bn, but it still does not beat the comparison based sorting algorithms. What if we make the value of b larger? What should be the value of b to make the time complexity linear? If we set b as n, we get the time complexity as On. In other words, we can sort an array of integers with a range from 1 to nc if the numbers are presented in base n or every digit takes log 2 n bits. So here now we are going to see about the applications of the radix sort in a typical computer, which is sequential random access machine, where the records are keyed by multiple fields. Radix sorts is used. For example, you want to sort on 3 keys month, day and year. You could compare 2 records on year, then on a tie on month, and finally on the date. Alternatively, sorting the data 3 times using radix sort, first on the date, then on month, and finally on the year could be easy. It was used in card sorting machines with 80 columns, and in each column the machine could punch a hole only in 12 places. The sorter was then programmed to sort the cards depending upon which place the card has been punched. This was then used by an operator to collect the cards which had the first row punched followed by the second row, and so on. Key points about the radix sort. Some key points about the radix sorts are given here. It makes assumptions about the data, like the data must be between a range of elements. Input array must have the elements with the same radix sort and width. Radix sort works on the sorting based on individual digital or letter position. We must start sorting from rightmost position and use a stable algorithm to each position. Radix sort is not an in-place algorithm as it uses a temporary count array. And here are some of the flowcharts of the radix sort where you can see the begin radix and radix sort is divided into two types: LSG radix sort, MSG radix sort. It starts sorting from the end of the strings, the least significant digit. MSG radix sort, it starts sorting from the beginning of the strings, the most significant digits. In this article, the task is to discuss the MSG radix sort and compare it with LSG radix sort approach. The idea is to perform the following steps for each digit I, where the value of I varies from the most significant digits to the least significant digit. Stores elements in different buckets according to the right digit. Recursively sort each bucket that has more than one element. Moves towards least significant digit radix sort. The idea is to sort the fixed length integers. MSG is more efficient than LSG that may not be have extreme every digit of integer, and here it is an example of the MSG radix sort, that is most significant digit radix sort, and only green highlighted elements are examined and compared. So you can see that 167, 123, where the first significant digit has been grouped into two boxes, and where the next one is second and third one is 4, and after this they have checked the second least significant digits, where you can see that 276 and 273, the 3 comes before the 6, so 273 has been assigned first and second is 276. MSG can be used to sort strings of variable length. Unlike LSD, LSD has to be stable in order to work correctly, but MSG can either be made stable or unstable, and MSG can work with random strings. And here is the MSG example, not only for integers, for also for strings. See, we can see that BAD and BAN, where D has been came first because D lies in alphabetical order first, then N, and here also COF, COM, COM. Time complexity, LSG radix sort. Best and worst case time complexity is O brackets n star m, where m is the length of the longest string. MSG radix sort. Best case time complexity is O brackets n, and the worst case time complexity is O n star m, where m is the average length of strings. Auxiliary space, LSG radix sort. O brackets n plus b, MSG radix sort O n plus mb, where m is the length of the longest string and b is the size of the radix. MSG uses recursion. Recursion is nothing but calling a function in a program multiple. So it requires more space than LSD. This means that MSG is much slower than LSD when working with a few inputs. Implementation of MSG radix sort. So the MSG radix sort can be implemented using the linked list. Implementation of integers using linked list. Fixed length array of every node will take very large amount of storage. So we can know that the linked list is nothing but combinations of nodes where one node is connected to the other node by using a pointer, and the node consists of two, one for value and one for pointer. And here is the program for MSG radix sort. We are defining counting sort, and n equals to length of the array, and this is the program. The output array elements that have been sorted are initializing the count array, and storing of the count of occurrence, and changing the count so that count of contains actual position of the digit in output array. Building the output array, copying the output array to array, one more array, and methods of the radix sort. We are defining a radix sort and finding the maximum number of the digits, And here we have taken the array of 170, 45, 75, 98, not to 24, 2 and 66, and we are calling the radix sort, and we are printing after the sorting. The output of the given is 2, 24, 45, 66, 75, 90, 170 and 802. Thank you.